Okay, my wonderful friends, I am gonna applaud Royal Institution because they are admitting we have a new physics, which the current model is totally wrong, and it always has been. And believe me, I have been doing this a very long time, and you see how much I've been worked. Every time somebody came out with something, I would go back and see if I could support it, or how I could deal with it with my basically my theory on dipole core. Okay, because you can't have a gigantic positive and a little tiny negative floating around it. That's it. It was insane. And anyway, what I have come up with is electron flood theory, was nothing but dipoles. And they talk about beam mesons decaying into electrons and muons. Well, what are electrons and muons? I'll show you what they are right now. Okay, again, now that I am a fair user and I don't steal anything. I am commenting on what they're going to say about this new kind of physics. This is the Royal Institution. These are the big guys. They got 1 million subscribers, and they are all, if you subscribe to this, you're deep into science. Now, are you a parrot? Do you just say exactly what they say? Or do you think? Now, this is a discussion with Harry Cliff, Paula Alvarez, Cartel, and Ben Alex. Now, I want to comment on this. Obviously, they're not going to let me comment with them, but I will comment as they talk, and I will speak to their statements, and then I would love to engage. But because I'm not really allowed to in most cases, this is how I'm going to engage. So I'm going to comment as they comment. So I'll pick out I'll just run right through it. It's kind of long, but I think this would be a good thing to just go at least, and I haven't even looked at it yet. So I don't even know what they're going to say, but I know they're saying there's a new kind of physics. And the only reason they're saying that is because I showed that particle, and I just showed it to you. I can separate light. If you can divide light, that's the key. There's nothing further than that I know of. They're trying to divide particles of photons billions of times bigger, literally billions of times bigger than the particles that we're using, which are light particles. They're the smallest particles that exist. And then we split them in half with fission. So this is a new physics. It's literally absolutely new physics. The core is nothing but particles. The core is made of electrons. Every photon is 2 electrons, and then you start to build bigger and bigger and bigger balls of electrons until you hit 1 proton, and 1 proton is 1839 electrons. 1840 is a neutron. We're going to get deep into this. There's a lot to it, but it's not that hard. It's very, very simple. And as you stay with me going through this, I will comment on what they state. And then I'll say, well, here's how I feel about it. Maybe I'll say, yeah, that's exactly right. I have no idea. But I know they realize now we are in the new physics realm. And they knew this years ago. And they've been trying to prove me, because I did this 6 years ago. I posted all of the stuff that they're going to be talking about 6 years ago and sent it to everybody. And even I went to the University of Geneva. I went to the University of Geneva as a student in particle physics, and I interacted with whoever it was. I don't know who they were, whether a tutor or professor or whatever it was. And they actually ended up saying, wow, that's amazing. We'll follow you. I'm not kidding you. And I thought they were just joking. But obviously they followed me, because now they're doing exactly the same thing. And it's a glacial pace in this realm of scientific. Everybody wants to protect their own turf, and now they realize, well, we were wrong, and now there's nothing we can do about it. The guy's showing these particles. We can't hide from it anymore. Basically, that's what I'm seeing. If I'm wrong, you tell me that my stuff is wrong. I want to hear it from somebody big, because I can't hear it from anybody. Nobody's can accuse me of being wrong. They just hide away from me, because their theories do not correspond to electron flood model of the nucleus, which is nothing more than a ball of electrons. There's no protons, there's no neutrons, they're made of electrons. Anyway, let's get started. Okay, my good friends, here we go. This is, like I said, the Royal Institute. Let's go right back to the beginning, and here it goes.
Well, thanks, Martin, and really nice to be talking to you all. I should start by saying I'm really just the warm-up act for the two real experts who you'll be hearing from in a little bit. So you'll be hearing shortly. You'll be hearing from Paula Alvarez Cartel, who is a new lecturer at Cambridge and also one of the leading players in this exciting result. And she's going to tell you a lot more about specifically what's been found. And we'll also be hearing from Ben Alalac, who's also a theorist at Cambridge. And Ben is a real expert on the theoretical implications of these anomalies. He's been thinking about them very hard for the last few years. So you're really hearing from the sort of top people in the world tonight on this subject. So I'm just really here to kind of give you an intro and set the scene a little bit. So hopefully in the last, maybe about a month ago at the end of March, there were physics sort of broke into the headlines. So we have a number of different headlines in the BBC and the Guardian and the Mail and lots of other outlets reporting that an experiment at the Large Hadron Collider had seen tantalizing evidence for something new. So this is really exciting because at the LHC, we've spent the last 10 years searching for signs of something beyond what we already sort of understand, and we haven't seen anything conclusively yet. But this is perhaps the best best evidence so far that we've seen of something altogether new, and that's what Paula and Ben are going to be talking about shortly. So just to begin, I'm going to explain this. This result comes from the Large Hadron Collider, which, in case you're not familiar with it, it's the largest scientific instrument in the world, a 27-kilometer circumference particle collider that's based just outside Geneva on the Swiss-French border.
I think I mentioned this before, but I did go to the University of Geneva particle physics, online through Coursera, and I had interaction with them. They said they were going to follow me after seeing my acceleration of light and the particles. And I thought they were just wanting to get rid of me, or I get lost, because I said, do you want to interact? And they said, no, we'll follow you. And I said, okay, well, whatever. Anyway, so that was all. That's the last interaction I had with them, but here it goes.
And what the LHC does is really quite simple and brutal. It essentially accelerates subatomic particles called protons around this 27-kilometer ring, accelerates them to enormous energies, and then they're smashed into each other inside gigantic particle detectors, which...
Now, I want to say another thing right now, just in case he doesn't say it. There is literally hundreds of billions of particles they crash. We use 2 particles. So we use a couple of particles. And so we see literally the particle itself instead of just all of the debris after the concussion. All right, so let's keep going here.
Which are referred to as the experiments. And there are 4 of these detectors at CERN, but this particular result comes from the one that Paula and I work on, which is called LHCb. And this is a picture of the detector underground, just outside the town of the French town of Verney-Voltaire in France. And it's essentially a gigantic 3D digital camera whose job is to record what...
All right, did you hear what he said? A 3D, so they're taking it from every different angle. Digital camera, that's what we're using, is this digital camera. They're CMOS, which is metal oxide silicates that react to certain frequencies of light. And any extremely energetic particle gives off certain frequencies of light, and we can see them in cell phones. The stuff I showed you was from a cell phone. And people, you can't see that. Yes, absolutely you can. And that's exactly what they're using too. Only is, something that costs probably a little more money.
Happens in these high energy collisions produced by the Large Hadron Collider. So to understand what LHCb does, I'm going to have to give you a very quick introduction to particle physics, just take you through the basics. So hopefully you're aware that everything in the universe that we know about, at least, is made of atoms. And as we all learn in school, atoms are comprised of particles called electrons.
All right, before he goes any further, I just want to show you what electron flood theory says. I think everybody knows that they claim right now there's big particles in the center called neutrons and protons, and they make up the core. And then outside of that, hold on, I have little examples here. Outside of the core is what they call the electrons, and these are little tiny particles. So a proton wants to attract an electron, they say, but it can only get so close. Now that's just not correct. A proton, being a positive, would slam right together with the electron. So it never worked in the first place. Plus, why would this have the same charge, only negative, and this have the same charge, only positive, and be 1840 or 1839 times bigger. It doesn't work. So what really is happening is instead of these being neutrons and protons, they are balls of electrons. So this, as a proton, would be 1839 electrons. All right, it's dipoles. They're positive and negative. Then one more wants to get in because it's unstable. It's 1839. Once you hit 1840, it's neutral and it doesn't want to give one up or take one in. That's what neutrality means. A charged particle either wants to attract one more or push one away. Now, here's what an electron looks like, and here's one electron. All right, this is a dipole. Even though it looks like a little ball, it has a positive and a negative to it, and it's an electron. You take two of these together, and it makes a proton. I'm sorry, a photon, which is two electrons. So they have a dark side and a white side. Each one of these is an electron, back to back. It's like two-bar magnets, and they control a negative region. The negative reaches out. The black pulls in. All right, so there is no black out here. All there is out here is concussive white electron energy. Nobody ever knew about the black. The black was just obscured. It was dark energy. They just couldn't figure out where it was. It was attached to the electrons. Now, when you start to build molecules and atoms, the dark matter is so pulley that it pulls all the white ones in. Well, the white ones don't want to get too close to each other, so they surround the black and push the blacks to the center. That gives you a black hole, literally a black center. And then the explosive ones collect around it. Now, it reaches a point of neutrality where the center is just as attractive as the outside cores. I mean, the center will always be more attractive, but it'll reach a point where it's so coated with electrons it won't take anymore. But more want to get in because the black is so attractive. So they cloud in the quantum states outside. The white particle, which is the one that really wants to get to that black particle, will face the black core. And the black other side of every electron will face outwards. And then they will just collect one after another it depends on how many you have in the center, how many they want to get in. And you just get bigger and bigger and bigger snowball of particles wanting to invade because more and more black matter in the center means more and more attractiveness. So the black has more attractive force than the white. All right, so the black has more attractive force than white has repulsive force. The white repels, but the black is so attractive that even though the white is repelling, it'll still try to attract more and more whites, even if. Yeah. Okay, this goes back to June 2016. That's like 5 years ago. Now, this was my old channel. I had to shut it down. It was so badly attacked, I had to get rid of it and start all over again. And now this is my theory back then. Light is dark energy until it hits matter and bounces off, which is pretty much true. It's how much the Earth is growing per hour. All right, these are particles. Oh, I did the calculation to figure out how many photons hit the Earth and how much the photons weigh per hour, per square meter, and all that. So that's how big the Earth is growing per hour. Look, here it goes. This here is how much the Earth is growing per hour. All right, these are particles that were captured by Rodney Warren. He's doing the experiments, but I believe this is a torus. Now, this was 6 years ago, 5 years ago, that I did the videos and so forth and confronted everybody about it, but we were working on this for years before that, so it's not something brand new or anything, and it just goes back a long ways. And you're going to see exact same things. Nothing's changed. It's just that now they finally decided, well, we better start looking at this. We're starting to look kind of foolish. And somehow the electron activity does what you would think of. I think it might be capacitive inductance, and it's almost doing like an AC thing. I mean, look at it. The white's here, a little white spike coming out here, the white's over a spike here. I think it's doing a flip-flop inside there, like AC. Basically, it does. It wobbles. Now, I came out here to show the green electrons are identical to the red electrons, no difference. And I showed all this to CERN and to all of them. And this is the wave, and the particle is way back here. Remember, that particle looks just like this. until it concusses at the venturi, which is way out here. The forward leading edge of the wave is the impact zone, and all of the particles that are in front of it also have huge impact zones around them, so they glow. But this is the real killer glow. Now, let's see what I did next. This just shows that light spins. And these are not interference patterns of a flip and a flop and a this and a that. This is a single slit, but it's formed in the shape of a venturi. And we can see that this is virtually a drill bit of light. It spins. It's obvious. I mean, a kid could see that. And it literally is this right here. It's a particle, and we know what the particle is, and the particle spins just like this. Come towards this way, it spins this way. See it? Some spin off to that side, some spin off to this side. Most of them end up going in the middle, because there's a million of these things coming at it. It's not just one. So there's some way over here, there's some over here, there's some over here, there's some over here. So that's why, but whenever they come through, they say, get out of my way, you get out of my way, you get out of my way, you get out. And that's why they form these stripes. They are not what you consider to be the traditional interference patterns. And you notice they're on one side and not the other. All right? And that's significant because these are impacting on top of the venturi and concussing earlier, and these are not impact. It's a architectural thing, a geometry, whatever you want to call it. It impacts here first and dips under there. All right, it's spinning to the right-hand spin. So the particle is impacting the separation, and it's spinning under over here. Now, you've seen the kind of stuff I just showed you, and they have too. It was 6 years ago. So I've seen a lot of cartoons and little drawings and doodles that they've shown, but I haven't seen anything that anywhere near approaches what I'm showing. So if you can present that to me and date it back to this time frame, I'll give them credit. But right now, they have to give us credit. All right, here it is, 2018. Step aside, CERN. There's a cheaper way to break open physics. Tabletop experiments could find evidence of new particles beyond the standard model. That was us. You know, somebody else took credit for it. And I've tried to contact this guy, and I've never got anything back from him. You saw I had a 2016. This is 2018. I've been communicating with these guys for years, and nobody ever commented back. But eventually, somebody had the guts to step up and say, well, we got another way to do this. And I applaud him for doing that, even though it took a pretty good amount of time. See, and then CERN came out and they said the same thing. LHC is a photon collider, coming particles together, smashing one, doing exactly what we did. And they said since 1978 they wish they could do this, but couldn't figure out how to do it. Where is it? It's down here, but they talk about it. They're billions of times bigger than, here it is right there. Physics of photon collision, been a big topic of some interest for many decades. In a special meeting in 1978 to try to figure out how to do it. They couldn't do it. So they said the collisions are very clean as we're colliding photons, which are elementary particles of light, not composite ones like protons. All right? And the protons are billions of times bigger. Look at this, 100 billion times particles are bigger. All right, than the ones we're using. That's why they're digging through debris. They're never, ever, 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 ever going to figure out what the thing was made of. Remember I showed you, I think this is that reverse spinner. It's not the same as any other particles I've ever seen. And it did this after it impacted with another Higgs field. These are, I believe, what they call the Higgs fields. And I'm just making these statements. Now, if I'm wrong, let them tell me I'm wrong. But nobody will contact me to say I'm wrong, and nobody will contact me to say I'm right. And like I said, Geneva, they said, we'll follow you. And I believe now that they were honest in that statement. Remember I showed you a Higgs field change color? Now, this is very, very unusual and rare again. You see these two particles here on the sides? Somehow the fields cross path, and these are pushing so hard both directions at the same time that it crushed one of these and squirted it out like a toothpaste tube. And you see how it elongated the particle? The particle's field effect. It's almost like as we were accelerating out of the wave before. I showed you that. Now, and then it immediately settles back. I mean, instantaneously, it's going to come back to this same color, obviously, I think. Well, I can see it. Look, you see how far it is out ahead of everybody? Can you see that way out here? Yes, you can. And it's back to red now, about the same as this. But it just shot it out like a cork. That to me is pretty interesting. So what it had to do is add energetic value, because it made it squirt out like a gun, like shot like a bullet. There's a lot to consider here, a lot to think about. And that's what I'm doing. I'm thinking. I'm trying to think anyway. All right, I know I went through a lot of stuff, but let me just finish up quickly my research, and then we're going to go into the Royal Institution, and we're going to play one against the other. Now, this I am claiming is a standard light wave from a red laser, and the particle is back here, and it looks similar to that. And this is the particle right down here. And the only time we see them actually turn into that box configuration is just before they concuss and separate at the Venturi, which is right up here. So this particle back here, it's in the wave and it looks just like that. As it's accelerating out of the wave, I'm really not sure. Well, I know what it looks like actually. I can show you. Well, as a matter of fact, I will. And then it explodes here at the Venturi. Let me show you exactly how that happens, because back here, there's no definition to it. You don't see it looking like this. Back here, it's starting to separate its charges and ripping one from the other. And that's what I feel now is happening. And then here, they stack up because they can't rip away from each other like they can here. Here, they begin to stack up, and that's when they turn into this. Now let me show you this. This is, and then of course after, as they come out of the Venturi, they come out shortly after, right here, they turn into these Higgs fields. And from here to here is this electron shower. And that's that particle, that flaky little thing. Now, the blue I told you is very, very fast. It's spinning to the right, drifting to the left. That's exactly what you expect to see. You can see it's accelerated here, I believe, and slowing down here because it's the same thing through the Venturi. But you cannot really make out the particle, I don't think. Maybe you can. We didn't do much with blue. Green is absolutely identical. The green is no difference whatsoever. Now, as a matter of fact, here it is. Here's what the green does. Same thing, exactly identical. So let's get past that. And you can see the spikes. Let me show you the green really up close and personal. You see this? This is what happens just as it impacts to the Venturi. They create that particle, little glow. And you can see the white sticking up and the white sticking up and the black and the black. It's sort of a concussion event. And well, it is exactly a concussion event because I can show you the red ones as they concuss. All right, now, pay attention close. All right, we're starting to accelerate the light here. And at this point, we're seeing like a little Oreo-looking cookie with a white in the center and a black on each side. Now, why? Why is that happening? I don't know. But I can tell you what, as it gets closer and closer to the Venturi, they begin to not have that sideways, they turn this way. And you get them flattened out, and then they start to make these little boxes. And then they get glowier and glowier, and then spikier and spikier. You see the red and the black spiking up and down there? And then it hits the Venturi, and it's explosion time. That's it right over there. You see that? Yes, you can. Now, that's the progression of light to the concussed state to the divided state. So here we are at the divided state, obviously, because the black is now removed completely from the white. These are the white electron showers. Just look it up, look up muon neutrino electron showers. There they are. And the black balls are the muons. Muon, neutrino, and muons. They don't do anything other than attract the white back again. And you can see exactly here, exactly there, exactly there, they reattach. And that is because they have such an affinity to pull the white ones back. Even in this extremely violent interaction, they will just hug right back up to them. That's all they do in life, is want to find one of these white balls to slam into. Now, as they grow bigger and bigger, I'm going to show this later. Maybe I already did show it to you, but this is electron flood theory. An electron consists of just half of one of these, All right, a photon is one of these two sides, so that bounces off of you, that electrocutes you because it wants to be incorporated. This one's already partially, okay, boom. This is the way atoms and molecules form. And the black matter goes to the center, the white particles, which want to be away from each other as far away as they can. They will end up surrounding it in that configuration. And then the next ones coming in want to attach, and they can't. They want to get to that black matter, so the white ones come in this way, and they can't get there, so they stick around in what they call a quantum state. And I think I went through, I know I must have gone through this, and sometimes you have to go through it 5 or 10 times. You may have to watch this video 10 times to understand exactly what I'm saying, but I think it's pretty basic and simple. And this right here is an increased value of energy compared to here. It's quite obvious. It didn't take anything whatsoever other than a Venturi. No intervention whatsoever. Once it's built, it's built. You don't have to do anything after that. The light comes in, it explodes, it separates, and this is where we have the separation of powers, and this is where we can harvest. I'm almost 100% certain. If I'm not, we could find out within a couple of weeks, and then you just say, Roger, you're an insane guy. We told you, and go away. They spend the money, they do that in 10 seconds over there at Fermilab. In 2 weeks, you could tell one way or the other. And really, you could have students do this, because this is sitting right on a tabletop with little tiny lasers, just little bitty things like this. And then you would have to have some kind of a harvest plate, and you'd have to have some kind of a device that would accept this increased energy and see if you could get more energy in there than it took to get through here. If that was the case, that's what's called free energy. And no matter what you did in a prototype and an early version of this, you would end up exceeding that by 10 or 100 times its value if you could make it, if you just prove that we can exceed the input with the output. The output exceeds the input, we're good and golden. And then you can go and change the material. You might go zinc, you might go aluminum, you might go copper, you might go a mixture of things. You might go rollers, you might do little Van de Graaff generator to draw off or push in electrons. You might use a Tesla coil to enhance the number of electrons that are in the air. Copper is an extremely reactive electron producer and concussor. And, you know, there's all kinds of different lasers you can use, and there's different configurations of Venturis. I mean, this is an unlimited area of exploration. I cannot do it. But I can tell you what, if somebody could figure out how to get, well, I know it's not a big mystery, it's just doing it. You need to put some harvest device in here just before it concusses air. Why let it just bang back into these electrons and go back into nothingness? Why don't you absorb them and use them to run a car, run your house, run your refrigerator, or air conditioning, whatever you want. And they don't have to be big. They do not have to be big. That's the beauty here. And they don't have to be ever done anything to. These are very, very stable devices, and they are, you know, you have to have obviously some kind of regulation, and you have to have some kind of output where you just bolt your outputs to a fuse panel just like you have now. Instead of being on the electric grid, you're on your own little electric box. There's a laser inside of itself. If it goes bad, you go down to Home Depot, buy another one, $129. I'm telling you, this is cheap. It should be very reliable. It's pollution free, 100% environmentally wonderful. It's portable. I see nothing. There's no drawbacks whatsoever. And if we don't do something about this planet, we are in big, big, big trouble. And I think we already are. I don't know if we can do anything yet now because it's pretty late. But if they'd have looked 6 years ago and said, you know, this is not a bad idea, let's look into it. No, they never did. They just it's a denialist system which creates this kind of end result. I'm sorry to say, it's just a fact. There has to be more of a form of an intervention to outside the dogma, because the dogma has dragged down science. That's the problem with science now. It's the dogma. The guy said, I figured this out, and if you want to stay in the business, you better keep saying what I told you to say. And that's just been the nature, and that is the nature of humanity, is to protect your own turf. But it's caused us a real serious issue here. Okay, change in plan. Originally I was going to do a gigantic video, and I think I will eventually incorporate this video into the next one, which goes through this whole thing, because this is almost another, this is going to take probably an hour and a half, 2 hours, because I'm going to go through this one that they put up, the Royal Institution, Royal Institution, 1 million subscribers. And they are going to talk about the standard model, which is a proton in the nucleus, protons, and electrons comprised of particles called electrons. Now, I don't know what they're going to say. I have no idea. I'm only into 2 minutes and 46 seconds, and I think I showed you the first part. But let me just go back here and say, they're going to talk, let me just go back to here where they're finding tantalizing hints of new physics, which is the particles I showed. That's exactly why they're finding them, because I showed
headlines in the BBC and the Guardian and the Mail and lots of other outlets reporting that an experiment at the Large Hadron Collider had seen tantalizing evidence for something new. So
now I want to see that tantalizing evidence, because I showed you my tantalizing proof. Now, I saw you show the particles. Now, are they going to show the particles? I'd like to see them. And they may show them. I don't know. Like I said, I just started.
This is really exciting, because at the LHC we've spent the last 10 years searching for signs of something beyond what we already sort of understand, and we haven't seen anything conclusively yet. But this is perhaps the best best evidence so far that we've seen of something altogether new, and that's what Paolo and Benny will be talking about shortly. So just to begin, I'm going to explain this.
All right, we don't have to go any further now, because I am going to be literally like in the conversation. So as they make statements, I'll counter their statement, and then we'll see what they have to say, because they won't be able to say anything. But I will try to make every different position. I won't take one side of it and say, oh, that's got to be wrong because this is my side of it. No, I'll say, well, let's see what they say. And maybe I am wrong. I don't know. We're going to find out, because we're going to go through the whole thing. But that's going to have to be another video. It's going to be very long and drawn out. So if you really want to understand particle physics and you want to confront me and you want to say, well, Roger, you can't be right. You can't do all this stuff. Fermilab, so got all these little machines and gizmos and all that. You don't have nothing. We have really nothing to work with, and no money and no support, and but we have evidence and we have results. So that doesn't mean just because we're not accepted that we're not right, because we are right, and they know we're right. And I believe, and I'm not kidding you, I went to Geneva, Switzerland. I didn't go there, but I did online through Coursera, and they said they would follow me. And that was like 2016. I showed you the video. I had sent that to them, and they said, wow, this is amazing. We'll follow you. And I think they did. And if they didn't, tell me you didn't. I showed my evidence way before you guys showed yours. And I show you yours, I showed you mine, and now you show me yours. And we'll see what you have to say. Now just keep thinking about my electron flood theory. I say nothing is made of protons and neutrons. They're all made of electrons. Hydrogen is, I've calculated it out with its atomic weight to be about 1,854 electrons. Helium is somewhere around 7,350-ish. When you get up to uranium and plutonium, it's 358,000 electrons make up, I think it was plutonium, uranium, one of them up there. But 358,000 instead of whatever it is, 238. So a big difference in the number of particles and the way they separate. That's why you have this gigantic amount of radiation when big particles break, because they're sending off hand grenades. They're not sending off single little electrons. They're sending off chunks and masses of particles, because that's as they decay. Now, if we could take these, like Fukushima, I'm watching, they're having a hell of a problem over there with all kind of nuclear radiation. Now, there is a way, I think, to mitigate the nuclear radiation if you can get it before it gets too widespread, or even still maybe. And with a Van de Graaff generator, a Tesla coil, and frequency modulators, so that you can flood extra electrons in or pull electrons out with the Van de Graaff, because you can pull them out or push them in. In the Tesla coil, you can just create tons of extra electrons. Now, then you take a frequency modulator and you start shaking everything that's in that environment, and if you shake it at the right frequency, you will stabilize things. Now, you may have to really play around there before you get to that point of being able to do this. But I think that's worth the try, because that's otherwise you just have to wait for them to break and fall apart by themselves. If you vibrate them and shake them with the devices that I'm talking about, especially the frequency modulator, let me just show you how particles assemble, and then I'll leave it at this. And I want you to think about the electron flood theory, because this is all there is to it. That's it. That's the whole thing. Now, let me show you this other one to show you how particles actually assemble. And then the next video that I have, we're going to go through this whole thing and see what these top physicists in the world have to say. And then I will kick into my research against theirs, and we'll see as a debate. Now, they may not be able to speak today, but if they say I'm wrong, I would like to hear from them. Okay, this is a favorite. This is Bruss Pup. And as the pitch of the tone increases, geometric patterns will form and become more complex. Now, this is amazing resonance experiment. And in their pitch means more and more and more and more faster the vibration of the plate. Now, on that plate is going to be salt. Salt is a very polar molecule, NaCl. That's highly rich with electrons, and this has very few electrons. So it makes it into a dipole, basically. Now, watch what happens as the salt shakes. The faster the frequency, the more complex the pattern. Now watch. Very small frequency, you're going to see basically what hydrogen and helium would look like, which is on the very basic. You're going to have one core, and the maximum they could have would be 2 or 4 electrons around it. Now you see how everything shakes again? Now you're going into the second line here of the periodic chart, and you have what they call the rule of 8. Now you see how perfectly they could, once you hit the exact frequency, these are just exactly like the electrons. They shake and push each other back and forth, and they say, all right, everybody's shaking at exactly this frequency. Everybody establishes their own zone, and they push their dark matter into the center, and the explosive white matter surrounds it, and then, but each one of them creates its own little ball of resistance to everybody else. That's why these are push to shove, this is push to shove, so it creates a pattern. Now, when we get way out towards the end here, I don't want to go through the whole thing, but you get way out here, you get the same kind of patterns. Everything is push to shove. And it always is a vibration between polar molecules. So you end up with these elegant patterns. And these are literally what, in my mind, are bigger and 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 bigger molecules, or atoms in this case. And then when you hook a bunch of other ones into these, they grab a hold of some of these electrons, that one grabs a hold of somebody else's electrons, and you have molecules form. All right, and because it's all based on stability. If this is more stable attached to another molecule over here that bumps into it, it'll say, yeah, here, take 2 of my electrons, I'll take 2 of yours, and we'll hook together and spit those other extra ones out, and it gives off heat. Just like you're making concrete, you get the heat, crazy heat. Chemical reactions can liberate all kinds of particles, which we call electrons. Everybody's doing the same thing. Fermilab, same thing, looking for dark matter, and because it's the big topic now. Because I showed it, and it's everywhere. Everybody's looking for the same thing. So there's a new kind of physics. Is there a new kind of physics? Yes, there is. Electron flood. That's the new model, and nothing but electrons exist, and they form little particles like this: electrons, photons, and then bigger particles into atoms and molecules. All right, the next video will be extremely extremely deep, and it will be this whole thing, which is it's 45 minutes long, an hour long, whatever. It's going to probably be a lot longer than that by the time I'm done. And this just came out, so they understand the new physics is absolutely required. They have seen what I presented, and I'm almost certain, just exactly like the University of Geneva said, we will follow you, and I think they did. And now I think it's wide open for everybody to do this laser physics, which brings us down into the subatomic realm, tabletop physics. And that's what I'm hoping, and I'm going to talk just like I was part of the conversation. All right, I love you all. Thank you. All right, here we're still back in 2016. Here I'm showing a particle accelerating and being pulled directly out of the wave. It's obviously the light is now accelerated. That means there's no question Einstein was wrong. If you can accelerate it, it's not the same speed. You could slow it down, and you could say, well, obviously it's going through a different medium and slowing down. But you can't, if you accelerate it, there's no question it is not correct. Einstein's speed of light being consistent, it can't speed up. Anyway, and then the explosion here. Now, this was my old pointer, and I'd tap on the screen and go bang, bang, bang. People are real upset. So we're into the feather mode now. So I showed all this. I wasn't hiding anything. And all I did was ask for some interaction. Nothing, zero. And here's the Higgs fields coming out. And that right there is a reverse spinning particle. That puppy there is very unique. Because when it hit one of these fields, it divided in half. I don't know if I show it here. I don't think I do because it's so extraordinary. But there is some things and plus this is an elongated red particle. It is squished on both sides by other fields, compressing it, elongating it, turning it into purple instead of red. That is an increase in energy, and it literally squirting it forward. There's a ton of things to examine here. Right from here to here is the electron spray, is the white showers, the electron showers. And we need to put a particle collector right here. And instead of them having slam into here, to just reattach to whatever's in the air, which is the dark particles. Because this is the white, 100% white, no dark whatsoever. That means here is when they reattach to the dark. If we could get right here and have our own dark matter somewhere in a battery and just fill it up the battery, because then you still have all this. It's in its raw state of raw electrons. That's when you charge a battery, that's all you're doing is pushing more electrons into it. And these are the raw electrons. So as far as I'm concerned, this is free energy from here to where they impact out here. And if you put a collector there, we just harvested free energy. And if it exceeds what it takes to drive the input laser, which it absolutely should, we should be able to harvest free energy and run the device and never have to put anything into it, because lasers are extremely stable. And all you got to do is turn on the lights. Basically, that's all. It's just like a solar collector. If it's running, it's running. If it's not running, it's not running. And you could regulate how much output you wanted from the other side, the collection plate, by how much input side. It's as simple as that. And it's fission, but it's fission at the photons scale. So there is no danger of hurting anybody, and it can't run away. So it's not like nuclear fission. It is fission, but it's not like big particle fission where you're breaking huge chunks of particles and throwing bombs at people. This is tiny, and it's inside of an enclosure anyway, so it's not going to hurt you no matter what. And they reattach within, I believe it's 4 nanoseconds or something. It's like they're back together. So there's no way you can get in between it and get hurt. That's my point. This is free. It should be. And I think it's unlimited. All you're doing is changing molecules in the air to bringing the dark matter in and the electrons in and so forth, and putting them in somewhere and then drawing them back out again. That's all, because we have the ability to harvest and store. Well, we have now the ability, hopefully, to harvest for free. And the storage device, it's up to you. If you could run it right off of this, or you could run it as a storage device, or you could put a little tiny storage device in there and do both at the same time, which is pretty much what everybody would do. But you don't need a big device to do this. This is light, which is small, little lasers. The laser that Rod used was this tiny, a little tiny thing, only about this long. Well, here it is right here. It's the exact same one. That's it. That's all Rod used to get these light. One of these construction lasers, exactly like this. And then he used a cell phone to pick up the light signature. And he used a Samsung. Samsung seems to be pretty damn good. And all he did was put a couple of pins, literally pins or nails, which create a curved venturi right in front of the output of the laser. And then he used his cell phone to take pictures of it. I guess it must have been in the dark. I don't know. I didn't do it myself. He did it. But I have all the equipment to do it. I just didn't need to do it. And the stuff he did, and he's still doing it today. This was 6 years ago. So, and I was just working with him today, as a matter of fact. So there's no running away from this. We need to run towards this if we want to help the Earth. And I know nobody's got any PhD behind their name or any of that stuff. And that's why a lot of times I bring up all my papers, my old papers about what I did in the research and stuff. That nobody's ever going to know this because I didn't care about degrees. I just wanted the knowledge and the understanding. And I still do. And I still go to school through Coursera. It's free. Like I said, I went to the University of Geneva, and they said they were going to follow me, and I believe they did, because this is exactly what it is, and I'm seeing it all over the place now. CERN, step aside. There's new tabletop laser experiments that change everything, and then there's all kinds of new things about photon collisions and photon to photon interactions and all kinds of muons and all this business. And they tried to prove me wrong, and they couldn't do it. So I'm saying that this was our research. All of their trying to prove us wrong was based on our research 6 years ago. And if they didn't pay attention to it, then that's their own fault. Because I sent this to literally everybody. As everybody knows, I am not a quiet guy. This has been out there for 6 years, and it's still out there today. And today it's just as clean as it was 6 years ago.